A new development for shaft construction is now in production that is complementary to our microtunneling technique. Deep shafts often encounter difficult ground conditions, like high ground water pressure combined with layers of hard material. Everywhere there is an increased requirement to avoid dewatering during construction to avoid the associated settlements which can affect a wide area. The following animation will show how the jacking unit and the cutter boom can sink shafts quickly and safely in difficult ground conditions. The initial section is excavated, 1 to 2 meters in depth. The cutting edge is assembled and the first sections of concrete shaft are lifted in place. Due to their size, they normally are cast in 2 steps directly on site to avoid transportation difficulties. Steel mounting plates and tension rod fixings are cast into the concrete. Using a dummy frame, the attachments for the cutting boom are accurately positioned and welded to the steel plates cast into the concrete. The cutter boom is assembled to suit the shaft diameter and lifted into the shaft by a mobile crane and mounted onto the special attachments. Soil anchors are installed to provide the reaction for the jacking unit to push the shaft into the ground. A jacking unit is assembled and attached to the soil anchors and to the shaft sections with tension bars capable of supporting the weight of the shaft and controlling vertical deviations so that the rate of descent can be controlled in soft ground and to push on the shaft in hard ground. All operations are powered and controlled from the container on the surface. Stored data, together with the cutter boom's position, is shown on a graphic display, giving the operator full control of the sinking process. The cutter boom can either be controlled manually by the operator or set in automatic mode for cutting the required section. The shaft is kept full of water during sinking to balance the level of groundwater in the surrounding ground. The cutting arm moves radially from the center to the outside of the shaft. In soft soil, the cutting edge on the shaft is able to trim the excavation as it sinks into the ground. The cutting speed and the movement of the boom can be varied to achieve the best excavation rate. A slurry circuit transports the excavated material from the shaft to a separation plant on the surface. The cutter drum cuts and crushes the material to a granular size that can be handled by the integral pump. In sticky ground conditions, an additional feed line can clean the cutting drum. When it is necessary to excavate under the cutting edge, the machine can be fitted into an alternative position that is 1 meter lower. Before the shaft is lowered, the machine cuts out to the programmed limit all around the circumference where hard soil is encountered. The controlled descent in rock allows all of the cutting edge to be cleared before lowering. This avoids either trapping the cutter boom or causing the shaft to deviate. The flexibility of its telescopic arm, rotation and slewing movements allows the cutter boom to work in shafts without a diameter between 7 and 9 meters in water up to 40 meters deep. Precast concrete segments with rubber sealing gaskets are bolted in place on the top of the shaft. This can be done at the same time as the excavation to achieve good production. The moulds for the segments are also supplied as part of the shaft sinking equipment package. An automatic lubrication system reduces friction during shaft sinking. The total number of nozzles is designed to suit the soil conditions. When the shaft is sunk to the required depth, the cutter boom is removed and the base plug concrete is cast. The shaft is connected to the soil anchors to resist flotation. When the base concrete has gained sufficient strength, the water can be pumped out. The shaft construction has been completed without affecting the groundwater or the surrounding soil. The shaft is now ready for microtunneling activities. This method of construction can also be used for difficult shaft or foundation installations offshore, for example, bridges or wind turbines.